All right, in this lesson, we're going to be learning how to solve equations by using logs. So you want to make sure you get your heading on your paper. We already know one way to solve a log, or to solve an exponential equation. That's by using common bases, which I'll show you again today. And then we're going to learn a new way when we can't do common bases. So the first thing I want you to write is 2 ways to solve exponential equations. We're going to review the first way we learned and then talk about how and why we would not use it this way. So the first way is common bases. So when we have an exponential equation like 4 to the x equals 8, here's our exponential equation where we have our variable is our exponent. We can try to get these to be common bases. So can you write for me after common bases, rewrite each side of the equation with the same base, and then a comma, set the exponents equal to each other. Set the exponents equal to each other and solve. So I'm going to have us practice this one more time just so you can see when we would use common bases. So the example we're going to use is what I put on the post-it, 4 to the x equals 8. We want these to be common bases. So the first thing we do is we look for the smallest base, which is 4, and we're going to try to find powers of 4. So I'm going to go to y equals and type in 4 to the x and look at my table to see if I find 8, which I don't. So I have to go smaller. So a number that I can divide into 4 is 2, so I'm going to do powers of 2, so 2 to the x power. If I go to my table, make sure it starts with 1, I need to see if both of these numbers are there, which they are. So I'm going to change these both to bases, to powers of 2. So this 4 to the x becomes 2 squared with an x on the outside. This 8 becomes 2 to the third. So I have 2 to the third power. Next, I get rid of my parentheses. So this becomes 2 to the 2x power, and this is just 2 to the third. Since we have common bases, we know we can cross out the bases and set the exponents equal to each other. So we have 2x equals 3. Now to solve this, we get x alone by dividing both sides by 2. 2's cancel. If I use my calculator, 3 divided by 2, that gives us 1.5. So we're allowed to use common bases here. Another way to solve this would be using logarithms, which I'm going to show you that right now. So this is number 2, and we're going to put logarithm. And a short name of that is just logs. So this time what we can do is we can give the log to both of them, the common log, which is the 10. So I want you to write for me, give the common log. And common log means a log base 10. So I'm going to put in parentheses log base of 10. So we're going to give the common log to each side of the equation. And solve for x. Using the law. Log base b of a to the x power equals, now remember this rule, when we have an exponent in our log, we can bring it to the front by making it log x log base b of a. So we're going to be using this little rule. And the reason why is because we want to get rid of the variable that is our exponent. So just like if we had an equation that had 2x equals 8, to solve this we would divide both sides by 2. As long as you do it to both sides of the equation, it works out. Here we're going to put the log to both sides, and as long as we do it to both sides, it will equal out. So I'm going to try this same exact example, but I'm going to use the logarithm first. So we're going to write 4 to the x equals 8. This is all by itself, it's isolated, so what I'm going to do is I'm going to put the log attached to both of these. So on this side I'm going to write the log base 4, the log of 4 to the x equals the log of 8. Our imaginary base is 10, so I don't need to write my little log in there, my little base of 10. So now what we're going to do is we're going to use this rule where we're going to take this exponent and bring it to the front. So now we have x log of 4 equals log of 8. So as long as we do the log on both sides, it will be the same. Now to get the x alone, notice that this x is attached to the log of 4. So what I'm going to do is divide both sides by the log of 4. So that stays together. So we're dividing both sides by the log of 4. The reason why is because the log of 4's cancel out. And now we're just left with x, which is what we want. So x is going to equal the log of 8 over the log of 4. I like to write that out really quick before I solve it, just so I have it separate. So on the side, I'm going to have you write log of 8 over the log of 4. Now we can grab our calculator and figure this out. So I'm going to have my calculator look like this. So I'm going to do alpha y equals. Alpha is my green button, y equals is the top gray. I want it to look like a fraction, so I'm going to select number 1. On the top, I'm going to type in the log of 8. So we can use this log button since it's a base of 10. So log of 8 goes on the top. On the bottom, log of 4. If I hit enter, notice we get 1.5, which was the answer we got above. So x equals 1.5. So when you're solving exponential equations, when you have a variable that's an exponent, you can do this either way. If you do not have a common base, then you would resort to using logs. So now we're going to practice 4 examples doing that. And then we will go ahead and end. I want to put a little note real quick before we go on to our examples. So I'm going to put a little star. And can you write the last method, and law removes the variable from the exponent and uses your calculator to solve. So that's where you have your x as an exponent and you can't find a common base. So the next part is where we're going to solve. So can you write solve and round to the nearest hundredth? Solve and round to the nearest hundredth. All right, so here's your first example. 5 to the x equals 18. Since we have an exponential equation, first thing we could look for is for common bases, but there is no common base that we could use for both. So this is where we're going to use our logs. So what I'm going to do is attach the log to both of these. So my new equation is going to be the log of 5 to the x equals the log of 18. So I attached the log to both of them. The next thing we want to do is apply that rule where we can take that exponent and bring it to the front, because that way it gets it out of the log. So we have x log of 5 equals the log of 18. We wanted to get the letter all by itself, so that's why we moved it to the front. The last step is to divide by what's attached to the x. Well, the log of 5 is attached to the x. So we're going to divide both sides by the log of 5. These log 5s cancel out. So I'm going to bring down what's left just so I have it as one answer. So we have x equals the log of 18 over the log of 5. I'm going to grab my calculator and type that in. So to make it look like a fraction, I can hit alpha, the green button, and y equals, and select number 1. On the top, I'm going to type in the log of 18, and the log button's right here again, this button. On the bottom, I'm going to put the log of 5. The directions say round to the nearest hundredth, so that's 2 places past the decimal. So if I look, that's 79, but after the 9 is a 5, so I've got to round the 79 up to an 80. So it's x equals 1.8 or 1.80. Either answer is okay. The next one's just like it. Here's example B. 4 to the x equals 100. Feel free to pause the video to try this on your own, and then you can check back to see if you've done it right. There are no common bases that these two numbers share. So what I'm going to do is attach the log to both sides. So we have the log of 4 to the x equals the log of 100. Next, I want to get rid of this exponent, so I'm going to bring it to the front by using my rule. So now my new equation is x log of 4 equals the log of 100. To get the x by itself, I'm not going to divide by 4. I'm going to divide by the log of 4 since that's what's attached to it. So both sides I'm going to divide by the log of 4. These cancel out. I want to point out that you cannot cancel out these logs and then do 100 divided by 4. That does not equal 25. The log of 100 is different than just 100. So I'm going to grab my calculator, and this is what I'm going to type in. We're going to have x equals the log of 100 over the log of 4. So now I go to my calculator. I can do alpha y equals to make it look like a fraction. Hit enter. On the top is log of 100. On the bottom is log of 4. Directions say to the nearest hundredth, so I have to stop at this 2. Since the number after it's less than 5, I'm going to leave the 2 alone. So x equals 3.32. Two more. Here's example C. For C, we're going to write 3 times 2 to the x equals 4,680. Trying to give you all the examples you possibly could see. We do not want to attach the log to both of these yet because you want to isolate this power. So what we need to do is get rid of this 3. Since it's attached by multiplying, I can get rid of it by dividing by 3. So I'm going to divide both sides by 3. We want this to be all by itself before we do any logs. So the 3's cancel out. If I do 4680 divided by 3, we get 1560. So our new equation is 2 to the x equals 1560. Because this power is all by itself and I can't find a common base, I'm going to give the log to both sides. So we have the log of 2 to the x equals the log of 1560. Remember to give the log to both sides. Next, we want to get rid of this exponent, so my rule says I can bring it to the front. So now we have x equals, oops, I'm sorry, let me rewrite that. That would be x log of 2. And then bring down the right side equals the log of 1560. So now to get the x alone, I'm going to divide by what's attached to it. So the log of 2 is attached, so I divide both sides by the log of 2, not just 2. My log of 2's cancel out. So now I have x equals, I like to write out what I have for my answer. We have the log of 1560 over the log of 2. Now I grab my calculator since the directions said to round. Alpha y equals number 1. And I'm going to type in on the top the log of 1560. On the bottom, the log of 2. Rounding to the nearest hundredth would be this 0, but since it's 5 or higher after it, I change the 0 to a 1. So we get x equals 10.61. One more example. Last one. This is example D. All right, example D says 6 to the x plus 3 power equals 50. All right, first thing we want to do is we want to isolate the power, which it is. This 3 is attached to the exponent, so what we can do now is put the log on both sides. So we have the log of 6 to the x plus 3 power equals the log of 50. You give the log to both sides. Our rule says that we can take our exponent and bring it to the front. So normally we just have an x there, but we have an x plus 3. So I'm going to put the x plus 3 in parentheses since that was the exponent. That's going to go in front of the log of 6. I'll bring down the right side. We have the log of 50. Now, what I cannot get rid of this plus 3 yet until I move this log of 6 over. So what I'm going to do to get rid of the log of 6 is divide both sides by the log of 6. So we have the log of 6 on the left and the log of 6 on the right. These cancel out. I don't just have x here, I have x plus 3, so I'm going to bring that down, x plus 3. On the other side, I'm going to bring what I have left. So I have the log of 50 on the top and the log of 6 on the bottom. We are almost done. We have to isolate the x. We have to get the x alone. So in order to cancel out this plus 3, we're going to subtract 3. I put it on the side because I can't combine it. Why I did that is our 3's cancel out. So now what we have is x equals, I'm going to write what I have. I have the log of 50 over the log of 6. So that goes first. So log of 50 over the log of 6. And then I have minus 3 after it. So that's what I want to type in my calculator. I couldn't have gotten rid of the 3 until I had to get the log away from it. So now I'm going to grab my calculator and I'm going to type this in. So I go to alpha y equals, select number 1. On the top I put the log of 50. On the bottom I put the log of 6. Now after it I want minus 3, so I'm going to arrow to the right to get out of that fraction and subtract 3. Now I hit enter and there's my answer. Rounded to the nearest hundredth would be where the 1 is, but since the number after it's 5 or higher, that becomes a 2. So our answer is negative 0.82. So anytime you have an exponential function, you can attach the log to both sides in order to solve. Please make sure you submit your notes into Canvas to get credit.